This question has so many possibilities. There's so many things that we can do with it. I could ask you to give me the equation of the line. I could ask you to give me the equation of a line that's parallel to this line and perhaps goes through another point. I could say it goes through 10, 12, right? So give me the equation of a line that's parallel to the one that goes through those points and goes through 10, 12 instead. So if you think about, whatever you're asked for, right? So there's some point, it's 100 units over 112 up. So I'm just going to roughly sketch this here. And then I go back 60 units and up 48. I'm just going to roughly sketch it here. So what I'm asking you to do is figure out what the slope of that line is. So, but I could also say, hey, give me the equation of a line that's perpendicular to it and maybe goes through this point, right? So now I've got two things, right? I want to know. So I want the equation of the line that is perpendicular to the one that goes through these points, right? And furthermore, is it goes through this point right here. So there's a lot of variations on things we can think about and do with these. Or like I said, you could consider the point that's going through over 10 up 12. Maybe I'm asking you, hey, what's the equation of a line that goes through this point that's parallel to this line? Or maybe I could say, what's the equation of a line that goes through this point again that's perpendicular, right? That makes a right angle with this point right here. So a good idea is to kind of just crudely sketch it so that you can think about what you're being asked to find. In this case, all I'm asking you to do is, hey, consider this point and figure out its slope. And I can see when I crudely sketched it that I know the slope of this line should be positive, right? Again, if I'm looking at way over here at 100 and 112 and then back 60 and then up 48, right? I can see that this should roughly be a positive slope. So that's kind of a good insight to have to start with. So I guess an important idea to remember is what the definition of a slope is, right? It's this rate of change. How much does the y value change in relationship to how much the x value changes, right? It's the rise over the run. It's the change in y divided by the change in x. And I think probably a smart thing for me to do right here on this video is to use two different colors. So I'm going to use change of y in red and change in x as green. So let's start by looking at the change in y values. So I'm underlining these. These are my y values. And I'm just going to start by taking this second point, which is 112, and I'm going to write minus the first point, 48. And you can see I went from the second point minus the first point. Now that expression represents my change in y, and then I'm going to write that over an expression that represents my change in x. And you can see here my this x is at 100 here and x is at negative 60 here. So same exact pattern, right? I'm going to start with the second point, write down the 100, and I'm going to subtract from that. Now, careful, I'm subtracting, but I'm subtracting a negative 60. So here's my definition of slope. I figured out an expression for the change in y, an expression for the change in x. Now let's go ahead and do the calculations. And yeah, I'm tired. So 112 minus 48 is 64. So I've got a change in x at 64 units, and I'm trying to be consistent with my colors here. And my change in that's my change in y. And my change in x, I can do that. 100 minus negative 60 is 160. So I'm looking at 64 divided by 160, and I could do this. I think that simplifies quite nicely. So I'm just going to go ahead and grab the fraction template. Again, it's alpha and then this F1 button, and you can see option 1 is the fraction. So I'm going to put in the numerator a 64, and in the denominator I'm going to put 160. And when I press enter, you can see that the calculator reduces that to 2/5. So this is equal to 2/5. And it's really important to write your slope this way because, look, if you're graphing this, there's no way you're going to go up 100 or 64 units and then over 160 units to the right, right? That's just not practical. But you could definitely travel from a point and go up 2 over 5, up 2 over 5. So there's a reason why we want to write this as a reduced fraction. An alternate way that you can get that with your calculator, if you just did the 64 divided by 160, right? It'll give you this nice decimal, but which is nice. That's 4/10, and I know 4/10 is 2/5. But also, if you were to press math, you can see the very first option up there is fraction. So just math, and then you just say put that into fraction. It gives you the 2/5 again. So the slope of this line, right? Slope is 2/5, right? It's got a rise of 2 and a run of 5, and it is positive. And this would be your answer for question number 7.